Okay, so we're looking at the intercept form. The intercept form is nice because it's written such that you see the zeros, the x-intercepts. So we can write the x-intercepts down. 3 makes this 0. -1 makes this 0. So there's our x-intercepts. The y-intercept we were talking about is always easy. All you have to do is replace x with a 0. So we look up here, and it's 2 times -3 times 1 because we replace x with 0, and there's our y-intercept. Now we need the axis of symmetry, and like we said, the axis of symmetry has to go down the center. So if you've got the intercepts, you just pick the middle. If they're decimals or that it's not even, you can't visually just see where it is, you just add up your x-intercepts and divide by 2, right? So I could say 3 plus -1 over 2 because it's the average, right? Now, once you find the x of the vertex, how do you find the y? You plug it in. So let's think about something in math. It's always easy to find the y-intercept, right? You don't have to work or factor, you just plug a number in, plug 0 in for x. Once you find the x value, is it easy to find the y that goes with it? Yes, you just plug it in, right? So remember, anytime you know an x, you can plug it in to find y. So let's plug 1 in here. If you plug 1 in, what do you get? You get 2 times 1 minus 3 is -2. 1 plus 1 is 2. So 2 times 2 times 2 is 8. And of course, there's a negative in there. So it's -8. And why am I writing a point? I should be over here. So that's what? 1, -8. Right? So I can go down. And there we are. The vertex is always going to be, and that's where I really should have crossed, right? The vertex is always going to be on the axis of symmetry, yes? Yes. Okay. What's the domain of all parabolas? There we go. We're never going to miss that question unless they restrict it and tell you you can only look, from 3 to 7 or whatever. The range is always going to be the y of the vertex. And then infinity, depending on whether it's upside down or right side up, right? This one starts at -8 and it goes up to infinity. Easy. This isn't bad, right? It's kind of cool. Okay, so now I'm going to give you, all 3 forms and you know how to use them. So now we're just going to look at random questions. A lot of times as you're doing your math, they're not asking you to do everything. If you're doing everything, it's easy because you start and you just go through everything. The hard part is you just get a question. Can you go straight to the question? So we're going to practice with that. So given the equation, find the characteristics. Probably only finding one. Find the vertex of -x² plus 4x minus 1. Well, first of all, it's got a negative, correct? In the front. So I would immediately start thinking, okay, it looks like that. If it's negative, it's upside down. So is it going to be a max or a min? It's going to be a max. And how do you find the vertex? -b over 2a, right? So let's identify a is -1, b is 4, c is -1. Once I have that, I don't have to look at them again. I just do -b over 2 times a. So that's -4 over -2, which equals 2. So I know the vertex is at 2. Now I'm going to plug it in to find y. Now remember, that negative sign is outside of x². In math, when you're going to plug a number in, if you will put parentheses everywhere where there's an x, this really will help you when we get into more complicated x's, like when it's x plus h and things like that. So open your parentheses and whatever x is, there's your x, put it in. This technique will keep you from making or help keep you from forgetting negative signs or asking yourself, do I put that negative in there? Right? So this is going to be 2 squared is 4. The opposite of 4 is negative 4 plus 8 minus 1. What is negative 4 plus 8? That's 4 minus 1 is 3. Find the axis of symmetry for x minus 2 squared. Well, when you see x and a number and they're squared, that's your vertex, right? That's the x. So this is at 2 and there's no k, so the vertex is at 2, 0. So what's the axis of symmetry? X equals 2. Find the x-intercepts for this guy. What are your choices for finding x-intercepts? Yeah, well, you can graph it, you can factor it, or you can do the quadratic formula. Now, I can quickly look at this and know that there's no 2 numbers I can multiply together to get -1 that are going to add up to 4. I know it's not going to factor. And if it won't factor, what does that most likely tell me? Quadratic formula is probably the easiest. So again, identify your A, B, and C. I'm going to give myself plenty of room. A is -1, B is 4, C is -1, right? All right, let's find our x-intercepts. What is the quadratic formula? Let's write it down one more time. And make sure that you know your radical goes all the way to the edge of the B for AC. Okay, so I'm going to do this. -b plus or minus. Now I want you to make note, B is squared, so you never have to worry about the sign. If you're using a calculator, don't type in negative number squared. If you forget the parentheses, it will come out negative. So right? Again, use your parentheses. You're better off to use a couple of inches of paper and get it right. And you really can't just plug it in and get a decimal. On problems like this, they're going to want a radical answer. So you have to do the steps. Okay, what is 4 times 1 times 1? 4. And is it 16 plus 4 or 16 minus 4? It is, because there's 3 negative signs. So it's a negative. So this is really and I'm writing every step. You may do a few of these in your mind. Okay, so now we got to simplify 12. We cannot divide the 4 and the 2 yet, because if all 3 of these don't divide, nobody divides. What is the square root of 12? Well, 12 is 4 times 3, and 4 is 2 times 2. We pull out the twins. If you need help on simplifying radicals, let me know. We can practice that when we're done here. Now, see, this is very important. This is one of the most common mistakes in math. What do you divide out? If there's a plus or minus sign here, you have to be able to divide every part. So those 3 parts have to be able to be divided by the same number. And if they can, then you're good to go. They're all divisible by -2, right? So what is our answer going to be? Wait. What's -4 divided by -2? 2 plus or minus. These are going to go, right? So there's your answer. So it's, and if we're to go there, there are x-intercepts. So that's it's 2 plus the square root of 3, and it's 2 minus the square root of 3. So you do get 2 roots out of that. This is not hard. It just takes some paper, right? All right. Find the range. What do you need in order to find the range? You need the vertex, don't you? You need the y value of the vertex. Well, where's the vertex here? -3, -1, right? And this one opens up, correct? So the y is going to be the top or the bottom? It opens up, so this is going to be what? The bottom, correct? Right? So it's -1 to infinity. If it were upside down, it'd be -infinity to -1. What is the y-intercept? Ooh, on E, y'all tell me what the y-intercept is. I want you to write it down. I'm not going to tell you for a second. Write down what you think it is. The y-intercept. Okay, what is it? Did anyone write -1 down? You don't have to raise your hand. If you did, you got caught in the trap. I'm very sneaky and mean on these cold days. Remember, if we're in this form right here, it's easy to see the y-intercept. It's -1. If you're in vertex form or any other form, how do you find the y-intercept? You plug 0 in for x. So what's 0 plus 3? 3. 3 squared is 9. 9 times 2 is 18. 18 minus 1 is 17. This one is tricky. If I gave this test to 100 people, I'd get at least 30 that would say 1. Because you're so used to looking at this last term. But think about it. When we're in vertex form, you don't necessarily get a 0 inside here, do you? So be careful with that one. And always take a second and plug in 0 for x. Find the direction this one opens. Again, I tried to trick you by putting the quadratic at the end. Remember, it's the term in front of the biggest power that determines. This one opens. Wait, that's a positive. Here, I'm writing the wrong thing. I wrote my marker through it. Yes, that's a positive. Sorry. All I saw was a negative for a second. That's because I'm sitting in the dark with the lights around me so you guys can see. Okay, find the domain. What is the domain always? It is. Okay, so do you feel like you're good with the parts of the parabolas and going in and answering one question? Okay, we have a few more things to do. Can you use a calculator? That's important too. So you've got to be what I would call bilingual. You must speak calculator and non-calculator. So I want to run one through with you and make sure that you're able to find maxes and mins. I think we've covered that, but just in case. So clear your calculator out. All right, so we're gonna, there we go. Now you can see. Now I can see too. Okay, so we're gonna type that in. I always laugh because we make you do things by hand and we don't give you the calculator. And then we're like, okay, now be a calculator wizard. Woo. Okay, so I want to make sure that you're very good. Write any steps down that you might need. So we're going to graph it. Oops, I am zoomed way in, as you can see. So I need to zoom. Hold on. Zoom 6. Zoom 6 will put you back in a square, or really a rectangle. Now I can see here that I need a little bit more of the y's, correct? It's going off too far. So if I go to the window, I'm going to look down here and say, I need more than 10 y's. I'm going to go for 20 y's. I don't want to just do a zoom fit. Sometimes when I do that, it goes out so far I can't see things. Okay, so how do you find the vertex? Make sure you write these steps down if you have any doubt. So you're going to go either second calc or second trace. It's the same button, so second calc, and you're going to want to do a 0. Now, don't slide around with the arrow. Just look. Would you all agree that -1 is on the left side and +1 is on the right side? So just type in -1, enter. 1, enter. And see how it put little lines there? Can y'all see these little lines? What it's done is it snipped out the part of the curve that it's going to look at for a minimum for you. And you hit enter, and it's going to say, whoops. All right. I was talking, so I want a minimum. And I'm going to do -1, 1. There we go. When it says to guess, you're going to hit enter again. And what is our minimum? What do you put? Well, first of all, let me ask you this. What's the vertex? I want to make a distinction. Right? There's the vertex. Everyone can see that in your calculator, right? But what is the answer to the question? No, when they want to know the minimum, they just are asking for the y value. If they don't say vertex, when you see what's the minimum in math, they want the lowest, or if they say maximum, they want the y value of the highest. You've got to watch the wording if they say vertex. Now, as we get in, we're using so many different math formats. If we find an electronic system that wants the whole vertex, they should say vertex. We'll have to play with that. But traditionally in math, if they just ask you for the minimum, they just want the y value. Okay? Real solutions. Are there any real solutions? No. Does it cross the x-axis? No, there are none. Okay. All right, let's do another one. I have so much disinfectant spray that my computer screen is. Okay, so let's go type that into your calculator. I need to wipe my screen. Y'all, that's all I do is spray disinfectants. They're everywhere. I use it. Oh. Okay, did you get that in? And we're going to see if we can answer. All right, we're going to graph it. Oh, that's nice. I can see everything. You could see that the zeros are not on integers. So we're going to need the calculator. So to find the zero, make sure you write down the steps if you need to. Second, calc 0. Now you have to tell the calculator where to look. Where is this 0? And you don't have to be right next to it. You guys can all see that this 0 is definitely between -3 and -1, right? So you just type in where it is. It's between -3, that's on the left side. A number on the right side is -1. When it says guess, you hit enter, and now I have my 0. 0.1. What do I do with that? How many decimals do I keep? If you have no instructions, keep 3 decimals until you get instructions. So one of those x-intercepts is -1.667, correct? And now you have to do the other one the same way. You can't find 2 at once. Second, calc 0. And we tell it, this one is between 0 and 2, right? So I type in 0, enter, 2, enter. When it says guess, I hit enter. And oh, that one was right on. The y-intercept, now I want to show you, of course you could see the y-intercept, it's -5, but also one of the things that we don't tend to know to look for on a calculator is the table of values. If you go second table, if you'll just look where x is 0, you can always see the y-intercept there. It's always visible. The x-intercepts aren't always visible if they're decimals, but the y-intercept is because x is 0. Where'd it go? There it is. We also need the vertex. So let's look at that. we'll want that number. So second calc, vertex is a minimum, right? And now here's my vertex. Would y'all agree that -2 and 1 are on either side? All you have to do is pick a number. So I'm going to pick -2, 1. And you notice how it puts little blue lines in. That's because your calculator is cutting out a piece of graph and saying, I'm going to find the smallest number right here where you told me to look. Okay, so what is that? -0.333. -5.333. If I didn't have a calculator, how would I do this problem? Yes, I would have to use a quadratic formula to find the zeros, and then I would have to use the quadratic formula to find direction it opens, of course, up. There's a possibility that this would factor. Those are 0.3. That's like a third. It might factor, but I could also use the quadratic formula. Where's my axis of symmetry? I'm going to outline, right? It's always going to match that, right? Domain and the range. Well, it's going to be bottom, right? To the top. Is everybody okay with everything you need to find in a calculator? Any questions about that? Basically, when you need something off of a graph with your calculator, remember the thing, you tell the calculator what you want, and then you have to cut out a small piece of graph. Your calculator is very narrow-minded, and you have to say, look from here to here and tell me what the smallest is, or tell me what the zero is. It can't handle a whole parabola at once. All right. What about this? Write an equation given the following information. What if I have a vertex and a point? Wait, what's the formula for a parabola again? What letters did we use? Did we use P and Q on that? Yeah. There's a reason for the P and the Q. Before calculators, we had to just try different numbers, and it was finding your P's and Q's, right? Okay, so you'll choose which of these should you use, right? When you're given points, usually ax squared plus bx plus c is not the way that you're going to find it. So this one gave us a vertex and a point. So what should we use? We should use vertex form, right? So the vertex, this is hk, correct? There's my h and my k. And what do you always know if you have a point? You know x and y. So we can just plug those numbers in. We're only missing a, right? So I could say y is 3, a times 2 minus 4 squared minus 1. Make sure that you know where those numbers came from. Everybody got that? Okay, so now we can solve. Now be very careful here. What is 2 minus 4? -2, but we're going to square it. So what are we going to get? 4a. Now, right here, your eyes may deceive you. Very common for people to say, oh, 4a minus 1 is 3a, because they're doing it in their head and they're not writing it down, but that's not true, is it? This has an a with it and that doesn't. So we now have to add that 1 over. And a equals 1. Well, that's dull. All that work and we get an a of 1. Okay, but how do they want us to write it? They want us, when you write an equation in math, you always leave x and y as variables in there. You plug everything else in. So this is really y equals 1. Now we don't write 1 when it's a 1, correct? So x minus h, which is 4 squared minus 1, right? I want to make sure you see that those 2 points came from there. Why did we do all of this work? Because we needed to know that. And we don't have to write it because it's a 1. Are you wrong if you write it? It's not wrong. I don't know if software will take it. Okay, what do I do if I have 2 points that are special points? What special points are those? They're x-intercepts, right? Yeah. So if I have x-intercepts, I can go straight to here. Now, they did not give me any additional information, and I think I put one on the other page. I gave you another one later where we have more information. If they don't give you any other information, you're going to go with the smallest polynomial you can get, and you're just going to leave a as 1. They might sometimes give us another point here. Or do you guys have another point there? This is weird. Yeah. I don't know why mine printed like this. Okay. Well, here's the goof up. I printed out the notes before I expanded them. If you're online, you have this additional point, which is good. I wanted that there. I was wondering, where did that go? Okay. So if they didn't give you a point, though, we could talk about this. You would just assume that a is 1 if they don't tell you. But they gave you another point. So what does that allow you to do? What is a 3 and a 10? It is what letters? X and Y, correct? So now let's think about what I can do. I can say, let me just write this down for a second. Y equals A, and then it's what? X minus 4 times X minus 8, right? That's how you would do that. X minus 4 and X minus 8, you can go from a point back to a factor. So now you have an X and a Y. You can now solve for A. This is really strange how, this is weird. What is 3 minus 4? -1. 3 minus 8? -5. So 10 equals 5A. A equals 2. That's more exciting. If we're going to do all that work, I don't want an A of 1, do you? So now our equation is Y equals 2 times, and you use your x-intercepts. Is that good? Can you do that? And kind of a rule of thumb in math, if they give you information like zeros and they give you an extra point, they say, oh, it goes through this point. More than likely, you are going to use that point as an XY so you can plug it in. Always think of that. If they seem to have just given you some random point, you're like, I wonder if I'm supposed to plug that in. More than likely it is. Okay, what about the calculator? Do you remember this? All right, let's go. I'm going to clear mine. And y'all, this is all disinfectant I have sprayed on there, so that's why it looks all weird. All right, so take notes on this. How do we do it? We have to tell the calculator what those points are. So you're going to go stat, edit. Stat, edit. So write that down if you don't know that. Stat, edit. And you're going to plug those points in. -1, 2, 5. So you put your x's in. Make sure you put in the y's in the same order as the x's. Tell me when you're plugged in. I got to make sure we're all there, because if you get lost. Okay, now you want to tell your calculator, here's 3 random points. Now tell me, first of all, why can't we do this by hand and just go back and use those? None of these points are special, are they? They're not a vertex and they're not an x-intercept. Here we had x-intercepts. That's why we were able to write the factors. Here we had a vertex and a point, so we were okay. We don't know where these are. One might turn out to be a vertex, but they didn't tell us that, so we cannot assume that. So now you're going to go stat, calc. Now I want you to pay close attention. This works for anything that you want an equation for. You just have to know what it is. We're studying quadratics, so you're going to go ask it for number 5. If this was linear, you would ask it for 4. If it was a cubic or a quartic, you'd go say, hey, I want this one. So you put your points into the stat edit, then you go tell it what you want. We want quadratic, so that's number 5. And then you just enter all the way through. This is basically saying, look at list 1, look at list 2. That's where you put your points. We could change those. If we had more than one list in there, we could say, oh, now try list 1 and 3. And you do that. And now you have A, B, and C. I'm going to write these down because I want to show you something. Well, actually, I'm just going to write it today. So what is this equation, right? Yeah, I did put it in. Easy? That's nice, right? This is so weird. If you look at the online notes, I wrote that on there. I don't know how I printed these out. That's okay. They're the same. They're just scrunched up a little bit. Okay. Write the equation of the parabola from the graph without a calculator. As long as you have a graph and you can see the vertex, are you good to go? Yes. What form should we use? Probably vertex, right? Well, anyway, what's the vertex here? If I know the vertex now, what else do I need to look for? I need to figure out what A is, correct? How do I know what A is? If I go over 1, 1 squared is 1. I should go up 1. So if I go over 1 and up 1, my A is just 1, right? If I go over 1 and up 2, my A is 2. If I go over 1 and up 3, my A is 3. It's very easy to find. What is A in this one? You go over 1, you go up 1, and you get another point. So what is A? A is just 1. So what's the equation for this? It's y equals x squared, and it's moved up 1, isn't it? So it's what? This is just the parent function moved up 1. And how do we move it up 1? We put a plus 1. All right. So I need the vertex and A. What's the vertex on this guy? What is a vertex 2 for? -2 for. And what is A? I go over 1 and down 1, over 1, down 1. So it's a 1, but it's upside down. So how can we write this one? Y equals A negative x minus h squared plus k. So x minus h, what's x minus -2? And y'all know that anyway, this moves it left, this moves it up. There we go. Now, what if they didn't ask you for this? Let's see, did I ask you on that? Yes, we did. What if I asked you to put this in the general form? What if I didn't want it in vertex form? Could you do that? Yes. Could you do that? Well, we would FOIL this out. What happens when you FOIL that? Plus this 4, right? Now finish that out, and what do you get? Right? So is it possible that when you're working in Math Lab or Delta Math that they will request a specific form they want you? There is, right? So you have to know what they're asking. This is always vertex form. Ax squared plus bx plus c is a general form, and it could be called standard form. I want you to know that some textbooks will call the vertex form standard form. I hate it when they do that, but sometimes they do. You got to watch for that. Okay, lastly, what about this guy? Where is the vertex? Is it 1, -10? That is -10. That's a 1. Yes, it is. What is A? If I go over 1, how far up do I go? 2. So A equals 2. Not hard to find your A, right? Now, if I were to go over 2, it normally would be 2 squared, which is 4. But if A is 2, that means I would go 8 up, correct? And that's what happens. If I go over 2, I'm at 10. If I go up 8, I'm at 2. So I would always check a couple of points, make sure everything's good. And how are we going to write this? Y equals A times x minus h squared, and then k, right? When you can see a parabola, you see h and k. Always, right? All right, last problem. I think. Yes, okay. I know this was kind of long. Let's do a real problem. I have bad news for you guys. Nobody just sits around and does math problems for fun. You're not going to go to your job and say, fine, we got to use it for something real. So here's something real. The formula h equals -2t squared plus 8t gives the height in feet t seconds after a ball is kicked. You'll remember these from our parametrics. How long does it take the ball to reach its maximum height? What is the ball's maximum height? How long does it take the ball to hit the ground? Much easier to work this out if you will draw a simple picture. So I'm going to draw the ground. That's green grass, right? So here I am. I kick a ball, right? There we go. So here's my vertex. Here's a 0, right? Of course, I know it's on the ground when I start because it says I kick a ball from the ground. Well, it doesn't say ground. If it doesn't say up, we assume it's on the ground. So what is the ball's maximum height? What part of this problem is that? It is. What part of the vertex? Yeah, it's the K, right? So K of vertex. If you think about what you need before you start, does it keep you from going down a weird path? Have you ever started a math problem and you just start doing stuff to it and you just start doing stuff and then you get nowhere and pretty soon you're doing math and you don't know what you're trying to answer? Have you ever done that? So let's identify what is it we actually need. We know we need the K of the vertex, so we know we need the vertex. Now it says how long to hit the ground. What is that? That's the 0. How long does it take to reach a maximum height? There's 2 ways I can find that, isn't there? It could be the h of the vertex, or it could be half of this time. Or I could just find the vertex and double it and see if that works. Let's see if we're really onto something here. So let's find the vertex. Let's see. What is the vertex? Let's pretend you don't have a calculator. It is, but what is that formula? Negative b over 2a, right? And you can, and I want to test that. I want to do it both ways. So we're going to put it, what is b and a in here? A equals negative 2, b equals 8. Do I have a c? There is no c. Okay, so negative b over 2 times negative 2. So that's 8 divided by 4, which is 2. So I've got 2 as my vertex. I plug 2 in. What do I get? 2 squared is 4 times negative 2 is negative 8 plus 16, which is 8. So it should take 2 seconds to get halfway, and I should reach a height of 8. Now, by the logic we used, if it takes 2 seconds to get here, it should take 4 seconds to land. Let's plug in and look for zeros and see if that backs up what we said. So 0. I'm going to write down all the steps in my notes. If I were doing homework, I'd probably factor at the same time, but I want you guys to see that. I'm going to take out negative 2t. What do we have? T minus 4. So this is. Of course, we knew that was 0, 0 because we're going to call that our starting point. Indeed, it did take 4 seconds to land, which backs up our theory that the vertex is 2, 8, right? Because unless, now if this was ground to ground, if I were to kick a ball off of a platform, like off of this table, then our vertex wouldn't be exactly centered, would it? Because I didn't land where I started. So we have to watch for that. But if you go ground to ground, that vertex is in the middle. Not bad, right? So let's answer the questions. What are the questions? It takes 2 seconds to reach a max height of 8 feet. It takes 4 seconds to hit the ground. And that's all of our fine notes for today. If you're watching, I hope you have a great day.